Under the quiet stillness of the night sky, the Pleiades appears like a small haunting ember. So close it feels almost touchable, yet in truth it rests more than 440 light years away. What lies hidden in that vast stretch between us and those blue stars? Dust clouds, newborn suns, or ancient traces carried across centuries of traveling light? This journey does not simply take us to the Pleiades. It reveals the story of every distance we are about to cross. And now, let us step into part 1, where the journey begins beneath the night sky. What really happens in the moment you quietly lift your eyes to the night sky and see that tiny misty cluster of stars we call the Pleiades? On a clear night, somewhere in the cool air just before midnight, you might step outside without thinking of equations or telescopes. You simply look up, and in the direction of the northeastern sky you notice a small blur of light, a handful of silver dust sprinkled on velvet. At first it looks like nothing special, just another group of stars among countless others. Yet as your eyes adjust, that faint blur sharpens into a tiny cluster, like a pinch of diamonds gathered by an invisible hand. That is the Pleiades, the seven sisters of myth, a place that feels close enough to reach with an outstretched arm, and at the same time is so far that human words struggle to hold its distance. Astronomers tell us that the Pleiades lie more than 440 light-years from Earth, which means the soft blue light reaching your eyes tonight left those stars before modern science was even born. About the time when Galileo was raising a crude telescope toward Jupiter and sketching its moons with trembling hands. So in that simple act of looking up, you are not just seeing a pattern of glowing points. You are receiving a message that began its journey centuries ago, traveling across the dark ocean of space at the speed of light. Carl Sagan once said that astronomy is a humbling and character-building experience. And you can feel that truth here very clearly, because the Pleiades quietly remind you that even an ordinary glance at the sky is also an act of time travel. Imagine a child in some mountain village long ago, centuries before you were born, standing outside a wooden house with no electricity, clutching a small oil lamp, and listening to a grandparent telling stories about 7 sisters chased across the sky. That child looks up at the same little cluster, perhaps feeling the same small shiver of wonder, and the same beams of starlight fall on that child's eyes as fall on yours now, only separated by the slow river of generations. In a sense, the light from the Pleiades has been a silent witness to our entire journey from myth to mathematics, from stories whispered around fires to equations written on blackboards. When a modern astrophysicist points a high-resolution telescope at the Pleiades, they see hot blue stars wrapped in delicate clouds of dust, filaments of reflection, nebula-like smoke caught in a beam of light, each star much larger and more luminous than our sun. Yet, when a shepherd thousands of years ago looked up, he saw something no less meaningful, a seasonal marker telling him when to plant and when to harvest, a celestial sign woven into the rhythm of survival. In many cultures, the rising and setting of the Pleiades marked the start of the sailing season, the beginning of ceremonies, the turning of the year. The Hawaiian name Makali'i, the Japanese name Subaru, the Greek story of the 7 sisters, all point to the same tiny patch of sky, suggesting that humans separated by oceans and centuries still found themselves drawn to this cluster as if it were a cosmic meeting point. Neil deGrasse Tyson likes to remind us that when we gaze at the stars, we are not separate from them, because the atoms in our bodies were forged in long-dead suns. That thought becomes almost tangible when we think about the Pleiades. For the young hot stars, there are now creating and sculpting the very kinds of elements that someday may gather into planets, oceans, and perhaps even living beings capable of looking back at the sky in their own way. So the distance between you and the Pleiades is not just a cold number in a textbook. It is a living story about what light can carry across the void, about what time does to memory, and about how our tiny lives plug into a far greater pattern. If light moves at nearly 300,000 kilometers each second, then in one heartbeat it circles the Earth more than 7 times. In 1 year, it crosses the immense gulf between stars. And in over 4 centuries, it stitches a glowing thread from the Pleiades to your retina this night. Think of how much the human world has changed during that span. Empires rose and fell. Languages shifted. Ships gave way to spacecraft. And yet the beam of light that left a blue star in the Pleiades, before any of that unfolded, is only now finishing its journey inside your eye. The distance is so great that if you could somehow fly in an ordinary airplane through space, never needing fuel or rest, you would have to travel for millions of years to cross that gulf. And yet, your brain compresses it into a single quiet impression, a tiny blur of silver in the northeastern sky. That mismatch between what is out there and how small it looks to us is part of the magic. It is what invites both science and story to sit at the same table. A scientist like Galileo might have looked up and asked, "What exactly am I seeing? How many stars are there? What do they orbit? How far away are they really?" A storyteller in the same age might have asked, "Why do those stars travel together? Why 7? What message are they sending us from the sky?" Today, with satellites and spectroscopes, we can measure their distance, estimate their age, calculate their mass. Yet the deeper emotional question remains the same. What does it mean for human beings to live under a sky where a simple upward glance connects us with events that began before any of our nations existed? Perhaps this is why the Pleiades continue to fascinate people on social media and in city streets filled with light pollution, even when the cluster is hard to see with the naked eye. Somewhere beneath the noise, we still carry the old instinct to search for familiar patterns in the sky, to find a cluster that feels like a tiny island of order amid the chaos of stars. As the physicist and writer Freeman Dyson once reflected, the universe shows us 2 things at once: our insignificance and our uniqueness. When you look at the Pleiades, you feel both truths together. You are one small observer on one small world. And yet you are also the only doorway through which that 4-century-old light can become a thought, a memory, a story told to someone you love. Picture a parent and child on a balcony in a crowded modern city. The sky washed out by neon signs and street lamps. But on a rare, clear night, they managed to pick out that little smudge of light above the skyline. The parent says, "Do you see that tiny cluster? Those are the 7 sisters. The light from them started traveling toward us long before anyone here had a phone or a car." The child squints, then suddenly sees it, the small glittering knot, and in that moment a bridge quietly forms between ancient shepherds, early astronomers, and this young watcher in the 21st century. That is the real power of the distance to the Pleiades. It is not only about how far, but about how deeply it threads together time, culture, and consciousness. So when we say that the Pleiades are more than 440 light-years away, we are really saying that every glance toward them is a meeting with the past. A soft collision between your present breath and a wave of starlight that began long before you were imagined. In the slow meditative act of simply looking up and staying there for a while, you allow the noise of the day to fall away, and you listen instead to what the sky has been quietly telling humans since the first time we walked out of the forests and into the open plains. The journey to the Pleiades may be impossibly long for our bodies, but for our minds and our hearts, it begins the moment we ask ourselves one simple question under the stars. What am I really seeing when I look at that tiny cluster of light? What does it really mean to leave Earth behind for the first time? To look down and watch the only home you have ever known slowly shrink into something you could cover with your thumb, as if all your memories and every story of our species were being folded into a single blue marble hanging in the dark. Imagine we are sitting together in a quiet backyard at night, the crickets singing softly, the air cool on your skin, and I ask you to close your eyes and picture the moment the engines ignite beneath a spacecraft. A deep, rising thunder in your chest, the ground trembling, your body pressed into the seat as if an invisible hand is pushing you back and saying there is no turning around now. As the rocket climbs, the familiar world falls away, the cities and highways stretching like veins of light, then fading under clouds, then disappearing entirely as darkness wraps around everything. In just a few minutes you are high enough that Earth is no longer a landscape but a sphere, a glowing globe of white clouds and blue oceans and tan continents. And you realize with a quiet shock that everyone you have ever loved is down there on that small ball. Astronauts have tried to describe this moment in simple words, yet their voices always carry a tremor. They talk about a feeling that something inside them quietly resets, priorities reshuffling without effort, arguments and divisions suddenly looking tiny because from up there are no borders, no lines, only one fragile world drifting in a sea of black. Now think of the numbers behind this scene, not as cold data but as the hidden rhythm of the journey. The edge of space is often said to begin around 62 miles above the surface, a distance you could technically drive in a single relaxed hour on an American highway. Yet that thin shell is enough to protect all life we know. The International Space Station orbits at a little over 250 miles up, roughly the distance from New York City to Washington, D.C. And from there, Earth already looks astonishingly round. The horizon curved, the atmosphere a fragile blue halo. But our story does not end in low orbit. It is only the first gentle step off the porch. To reach the moon, humans traveled about 239,000 miles from home, a number so large it can slip past the imagination unless we slow it down. If you drove a car at 60 miles per hour without ever stopping to sleep or eat or refuel, it would take more than 160 days of continuous driving just to cover the same distance as the gap between Earth and the Moon. And yet, in the scale of our wider voyage toward the Pleiades, that enormous stretch of space is almost nothing. No more than that first step off your front doorstep into the yard. Picture a child standing at the door of a farmhouse in the American Midwest, taking one step onto the porch while the fields roll away for miles in every direction. And far beyond the fields there are mountains. And beyond the mountains, an entire continent. And beyond the continent, the wide curve of the planet itself. The distance to the moon is that first step. The Pleiades is more like crossing, not just the continent, not just the planet, but hundreds of trillions of miles of oceanic darkness beyond any map we have ever held in our hands. when Apollo astronauts looked back at Earth from lunar distance. They described the planet as a small shining coin in the black, a fragile ornament suspended where there is no up and no down, only away. Some of them said they felt strangely torn, grateful to have come so far, but also aware that every additional mile stretched the invisible cord that tied them to their families and their history. If 250,000 miles can stir such emotion, imagine what it means to contemplate 440 light years, the approximate distance from Earth to the Pleiades. 1 light year is the distance that light itself travels in a year. And light is not slow. It races through space at about 186,000 miles every second, faster than any rocket we can build. In 1 year, a single beam of light crosses almost 6 trillion miles. And to reach those 7 bright sisters in the constellation of Taurus, that beam must run for 440 years without resting. When you stand in your backyard tonight and look up at the soft blue haze of the Pleiades, you are not seeing them as they are now. You are seeing them as they were when Galileo was a living man, when telescopes were crude, new inventions, and the idea of crossing even the Atlantic Ocean felt immense and dangerous. Yet before we can even speak about that epic gulf, we must linger for a while in this first layer of the journey, the act of leaving Earth itself. There is a kind of meditation in imagining our ascent step by step. First, the familiar noises of human life fading, the hum of traffic, the bark of a dog, the distant siren, then the muffled roar of engines, then only the soft whir of instruments and the slow breathing inside a helmet. Outside the window, the colors change. Blue becomes deep indigo, then black, and suddenly the world that once surrounded you is now below you. You see North America as a single shape, the curve of the coastline, the swirl of a storm the size of countries, the lights of cities blooming on the night side like a necklace laid over the dark. Someone down there is walking their dog. Someone is holding a newborn for the first time. Someone is watching a loved one slip away in a hospital room. And from up here, all of those stories flow together into one glowing sphere. For a moment you might feel a pang of fear, not because of the emptiness around you, but because you realize how much of what you call reality depends on that small orb continuing to spin in the gentle band where liquid water can exist. And yet anxiety slowly gives way to wonder, as it often does when we allow ourselves to sit quietly with the scale of things. The more you stare at Earth from above, the more it looks less like a random rock and more like a rare and delicate vessel, carrying forests and oceans and minds that can ask questions about distant stars. If you were to open a school atlas in an American classroom and trace your finger from your hometown to the opposite side of the planet, you might feel that you are covering a huge distance, across time zones and languages and cultures. But from the vantage point of orbit, your finger has barely moved at all. You are still tracing patterns on the same small marble. The step from Earth to the edge of the solar system is bigger than any journey humans have actually completed. Yet even that immense stretch is still just a tiny fraction of an inch on the cosmic ruler that reaches all the way to the Pleiades. Sometimes it helps to use a simple analogy. Imagine Earth and the Moon as 2 houses on the same American street. Maybe one at number 10 and the other at number 20. To go from Earth to the Moon is to walk from your front door to your neighbor's. A meaningful walk, but not an impossible one. Now, imagine that the Pleiades is not on that street, not even in the same town or the same state, but in another country, on another continent, across an entire ocean, and then across another. and still you would not be close enough to match the real distance in space. That is how enormous the step from our local neighborhood to the realm of the stars truly is. And yet our minds can leap it in an instant just by imagining it. There is something quietly beautiful in this contrast. Our bodies rooted to one fragile world. Our thoughts capable of roaming 440 light years without needing a single drop of fuel. So when we say we are leaving Earth, we are not only talking about metal and fire and engineering. We are talking about a shift in awareness, a widening of the frame in which we place our own lives. We rise from the ground of a single country, but as we climb, that country becomes part of a continent. The continent becomes a hemisphere. The hemisphere becomes a planet. And the planet becomes one more spark in a galaxy whose arms sweep across 100,000 light years. The road to the Pleiades does not truly begin out there in the darkness. It begins here, in the quiet recognition that Earth is our first spacecraft. Our shared vessel already sailing around the sun at tens of thousands of miles per hour. Once you feel that, once you let that awareness settle into you like a slow, deep breath, every upward glance at the night sky becomes the start of a journey. From that softened, humbled place, we are finally ready to continue outward, to watch the moon come into view as our first distant neighbor, and to sense how tiny even that great gulf is compared with the starlit path that will one day lead our imagination all the way to the Pleiades. What if everything humanity has ever known is just a small hometown in the dark, and the solar system is nothing more than the familiar road that leads out of it before the true wilderness begins? When we talk about crossing our own star system on the way to the Pleiades, we are not only drawing a map in space, we are also quietly asking a deeper question. How big is the world we think we live in? And at what point do we finally admit that our sense of distance was never designed for the cosmos? Imagine you are standing on a quiet street at night, the way many viewers might be in a small American town. Porch light glowing, distant traffic like a soft rumble in the background. You look up and see the moon, bright and gentle, and you know that somehow people have walked there. As a number on a page, 250,000 miles can sound abstract, but think of it this way. If you drove from coast to coast across the United States, say 3,000 miles, and did that trip again and again without stopping, you would still need to cross the country roughly 80 times to match the distance to our moon. That alone already feels enormous. Yet in cosmic terms it is just the first step off the front porch. Now picture our journey leaving Earth behind. Continents shrinking into swirling patterns of cloud and ocean. City lights fading into a soft glitter as the planet becomes a glowing marble. Below us, everything we care about is contained in a sphere only 8,000 miles wide, small enough to disappear almost instantly once we accelerate outward. Within days on our imaginary ship, the Earth-Moon system turns into a single bright dot, and the sun begins to dominate the window, a blazing disk that is at once familiar and suddenly alien. We pass the orbit of Mars, maybe 140 million miles out from the sun on average. And somewhere down there in the rusty dust, the Perseverance rover is taking breathless little snapshots, drilling into ancient rocks, looking for hints that water once pooled and life might have flickered. To make that distance manageable in your mind, imagine the drive from New York to Los Angeles. Now stretch that road until it wraps around Earth thousands of times. That is the sort of scale we whisper about when we talk of Earth to Mars. It is far enough that a radio message traveling at the speed of light can take many minutes just to say hello. And yet in the grand story of our path to the Pleiades, this is still just the sidewalk in front of the house. Further out, we reach Jupiter, the giant that could swallow more than 1,000 Earths and still have room to spare. Great storms circle its atmosphere, the great red spot larger than the entire Earth itself, a hurricane that has raged for centuries. If you could hover just above those clouds, the winds, screaming past faster than the strongest tornadoes we know, you would feel as if you were sitting on the shoulder of a living god of weather. For viewers used to thinking in miles, Jupiter orbits roughly 480 million miles from the Sun, a distance that would take a modern jet aircraft tens of thousands of years to cross if it could fly through space without stopping. Then comes Saturn, perhaps the most visually poetic of all our planets. Its rings thin as a sheet of ice and yet spread out over hundreds of thousands of miles. You could line up almost as many Earths as there are miles between the inner and outer edges of those rings, and still the structure would seem fragile, like breath on glass. Imagine dropping a pebble on a frozen lake on a winter morning, the ripples spreading outward in crisp circles. That is how Saturn feels to our imagination, a single planet whose presence sends delicate waves into the silence of space. As we drift beyond Saturn, we pass Uranus and Neptune, distant, bluish, cold worlds more than 2 billion and nearly 3 billion miles from the Sun, out where sunlight is weak and the warmth of home is little more than a memory. If the inner solar system is like a well-lit neighborhood, the region of Uranus and Neptune feels like the edge of town at midnight. Street lights thinning out, fields opening into darkness, and beyond them only the suggestion of a highway disappearing into the unknown. Still, our journey is not done within this so-called hometown of humanity. We continue outward to the Kuiper Belt, a vast ring of icy bodies, dwarf planets, comets sleeping in deep freeze. Here, at distances of billions of miles, a single orbit around the Sun can take hundreds of years, and many of these objects have scarcely changed since the birth of the solar system itself. In a way, they are the dusty boxes in the attic of our stellar home, filled with leftover pieces of the construction project that built our planets. Farther still, we reach the realm where the Voyager probes now travel, more than 14 billion miles away. Tiny messengers bearing golden records with greetings in many human tongues, on a map measured in light years. All of this fits into a space only about 0.003 light years across. If 1 light year is nearly 6 trillion miles, then our entire solar system from the Sun out to the distant edge where its influence fades is like a narrow driveway in front of a much larger estate. This is where a simple but powerful story can help viewers grasp the scale. Imagine the solar system as a house on a quiet street in America. The distance from the Sun to Neptune might be the length of the yard and the end of the yard. Driveway. The Kuiper Belt is the sidewalk and gutter, and Voyager at the edge of interstellar space is just beginning to step off the curb. Now place the Pleiades cluster not at the end of the block, not in the next town, but 440 light-years away. That is like walking out the front door and discovering that your destination is not another city, not another state, but the opposite coast of an entire continent multiplied again and again until the numbers lose meaning. In this sense, calling the solar system our familiar countryside is both comforting and humbling. It is the only region where we have left actual footprints, where our machines roll across alien soil and send back photographs that could hang on the walls of any living room. The red deserts of Mars, the cracked ice of Europa, the hazy skies of Titan. All of these are like neighboring farms and lakes that we have just begun to visit. Yet when we zoom out to think about the Pleiades, 440 light-years away, the solar system collapses to a single pixel in a sea of stars. For a meditative mind, this contrast can be strangely peaceful. We spend our lives worrying about distances that a car can cross, minutes on a highway, hours on a plane. And here the universe calmly operates with miles measured in billions and trillions, with years measured in the time it takes light itself to travel. Our familiar hometown of planets, stretching perhaps 18 billion miles across, is just a small clearing in the forest of the Milky Way. As we glide beyond the last whisper of the sun's influence, there is a stillness that feels almost like a deep breath between thoughts. Behind us lies the solar system, the countryside of humanity, full of stories, landings, failures, hopes carved into metal and silicon. Ahead of us is the long, dark path to Pleiades, 440 light-years of interstellar night dotted with distant fires. A road so long that even our words begin to feel too small for it. And as the camera of the mind turns forward, leaving the house, the yard, the town of our star behind, the question lingers gently in the background like a soft echo. If crossing our own solar system already feels unimaginably vast, what will it mean to travel all the way to those 7 blue stars shining quietly in the shoulder of Taurus? Have you ever wondered what it truly means to leave home, not just your city, not just your planet, but your entire star behind? Imagine we have already climbed beyond the blue shell of the atmosphere, leaving the quiet curve of Earth below us. The sun shrinks from a blinding disk into a softer white flame. Planets fall back along their orbits like beads sliding off a string. We pass the path of Mars, the storms of Jupiter, the pale rings of Saturn. One by one, the familiar signposts disappear until even Pluto becomes only a faint idea somewhere in the dark. At that moment, we step off the front porch of the solar neighborhood and into a realm astronomers call the space between the stars, the interstellar medium. Out here, there is no air to breathe, no wind to feel on your face. The temperature sinks to just a few degrees above absolute zero, which is about 454 degrees Fahrenheit below the freezing point of water. If you could somehow float outside your ship, your breath, your voice, your warmth would vanish instantly into a silence, so complete it almost feels like a physical weight. The darkness is not empty, but it is incredibly thin. On average, there may be only a few atoms in a space the size of a small room. Compare that to the air you are breathing right now, which holds trillions upon trillions of molecules in every breath. Yet when you look around, you are not blind. Far away, the Milky Way stretches like a soft river of light. Individual stars shine as steady points. Some glow with a cool red tone. Others blaze electric blue. But they are scattered so sparsely that you can feel the distance between them, like the distance between lighthouses along a dark coast. This is not the crowded inner city of the galaxy. It is the long, lonely highway between towns. To understand how far we have come and how far we still have to go, picture a familiar journey. Imagine driving from New York to Los Angeles, a road trip of roughly 3,000 miles. At highway speed, it may take you a week if you stop to sleep and eat. Now stretch that drive across the whole United States, and then across it again 1,000 times, then 10,000 times. Even that staggering distance would still be tiny compared to the 40+ trillion miles that separate the Sun from its next nearest stellar neighbor, Proxima Centauri, about 4.2 light-years away. If you kept your car rolling at 60 miles per hour without ever stopping, no fuel breaks, no sleep, no repairs, it would take tens of millions of years to drive a single light year. To reach Proxima Centauri, you would need longer than the entire history of the human species. And yet out here in this quiet dark, your destination is not even that nearby star. It is a beautiful little cluster much farther away, the Pleiades, around 440 light-years from home. Think for a moment about the fastest machines we have ever built. The Voyager spacecraft launched in the 1970s are racing away from the Sun at nearly 38,000 miles per hour. That speed could carry you from New York to Los Angeles in less than 5 minutes. It is astonishing by human standards. Yet by the standards of the galaxy, it is barely a crawl. At that pace, reaching even Proxima Centauri would take on the order of 80,000 years. A span of time so long that if Voyager had launched when our ancestors were still painting animals on cave walls, it would only now be arriving at our nearest neighbor star. This is why astronomers say that when we leave the solar system, we do not simply go somewhere else, we go into deep time. The distances are so immense that every mile traveled is also a journey through ages. Imagine a family deciding to set off today in a hypothetical starship that can move as fast as Voyager. The people who step aboard know they will never see Proxima Centauri with their own eyes. Their children will not. Their grandchildren will not. Dozens of generations would live and die aboard that wandering vessel before anyone looked out a window and saw Proxima swell from a point of light to a visible sun. Now carry that thought further toward the Pleiades. 440 light-years is more than 100 times farther than Proxima. At Voyager speed, the trip would take millions of years. So long that continents on Earth would shift. Mountains would rise and erode. Languages would be born and vanish. And entire civilizations would bloom and fade while the ship still sails between the stars. When you stand under a clear night sky and pick out that tiny spray of blue light, you are essentially looking at an address that no human technology can yet hope to reach within a single chapter of our history. And yet the mind travels there effortlessly. That is the quiet miracle of this dark space between stars. We may not have engines powerful enough to cross it in a lifetime, but we have imagination. Close your eyes and picture the solar system now far behind you. The orbit of Neptune shrunk to a small circle. The Oort cloud of comets now just a faint mist in the direction of home. Ahead, the galaxy opens like a vast plain. Every star is a possible sunrise. Every dim patch of nebulous glow, a place where new suns are quietly forming from collapsing clouds of gas and dust. Somewhere in that tapestry lie the 7 bright sisters of the Pleiades waiting. To make this more tangible, think of the ocean. Stand at the shore of the Pacific and watch the horizon. You know that somewhere beyond that line are distant islands and another continent. But from where you stand, there is only water and sky. Interstellar space is like that, except the water is far thinner than any earthly sea and the islands are stars separated by incredible gulfs. If a beam of light were a swimmer, it would still need 4 years to cross from our Sun to Proxima Centauri, even though it moves at the ultimate speed limit of the universe. 4 years of non-stop motion at more than 186,000 miles every second. The quiet out here has a strangely calming effect when you imagine it closely. No traffic horns, no phone notifications, no city glow bleeding into the sky. Just the soft radiation of the universe itself, a faint microwave hiss that has been traveling since the cosmos was young. It is as if the universe is breathing at a much slower pace than we do. In that slowness, our worries shrink. Our appointments for next week, our unfinished emails, our small daily victories and frustrations all seem to dissolve against the backdrop of 40 trillion miles to the next star. And yet this is not a cold, empty nihilism. It is an invitation to perspective. When you realize that the space between the stars is so vast, you also realize how precious it is that we exist together on one small world, sharing the same thin atmosphere and bathing in the same sunlight. The gulf that separates us from Proxima Centauri or from the Pleiades makes the distance between two people in a room seem almost non-existent. In that sense, every conversation, every shared glance, every moment of understanding is like a tiny bridge flung across a personal universe. As our imagined ship continues its slow glide, the Milky Way turns gradually like a great wheel. Somewhere behind us, the pale dot of the sun circles the galactic center once every 225 million years. Somewhere ahead, the spiral arm that holds the Pleiades curls through space like a river of light. We are mid-journey now. No longer within the protective bubble of the solar system, not yet within the bright cluster we seek. Suspended in the interval between familiarity and discovery. That interval is where reflection naturally appears. Between one star and another, there is room to ask questions we rarely dare to ask in the rush of daily life. What does it mean that our nearest neighbor is 4.2 light-years away? What does it say about us that instead of being frightened by that distance, we are compelled to measure it, to map it, to send fragile metal messengers like Voyager outward with golden records that whisper greetings in dozens of human languages? Perhaps the journey through the dark between stars is not only about reaching another sun, but about learning who we become when we face a distance we cannot cross in one lifetime. So as we drift in this imagined vessel wrapped in darkness and starlight, feel how the pace of the story slows. The mind breathes with the universe instead of against it. Somewhere far ahead, the Pleiades shines like a promise. Somewhere far behind Earth circles the sun, as it always has. Between those two lights lies the long, quiet road we are traveling now. The road through the space between the stars. What if the darkest places in our galaxy were not empty at all, but crowded with the seeds of future suns and worlds? When we leave the bright comfort of our familiar stars and drift into those great silent shadows, we are entering the hidden nurseries of the cosmos. Vast molecular clouds where light itself seems to disappear. From a distance, they look like black stains splashed across the Milky Way. Patches where the stars simply stop, as if someone has torn a hole in the sky. But in truth, these are enormous regions filled with cold gas and dust, stretching for tens of light years across space. Each light year about 6 trillion miles. So a single cloud can span hundreds of trillions of miles from end to end. If you could somehow steer a ship into one of these clouds, leaving behind the sharp pinpricks of the open sky, you would feel as if you were entering a dim and endless room. The walls made not of stone but of dust so fine it can float between the stars. The farther you drift inside, the more the outside universe fades away. Like a city seen through fog at night. Its lights are still burning, but their glow is swallowed by the haze. That is what these clouds do to starlight. They drink it in, scatter it, soften it until only a faint bluish whisper escapes. To a human eye, these places would seem almost completely dark. But if you could see in infrared or radio waves, as our telescopes do, you would find that the darkness is full of structure. There are filaments and knots, long rivers of gas, pockets where gravity has begun to tug the material inward, squeezing it tighter and tighter over millions of years. In those dense knots, the temperature can drop to just a few degrees above absolute zero, far colder than anything we can create in a simple freezer at home. Here, every tiny motion matters. Every collision between atoms and dust grains slowly redistributes energy, giving gravity a chance to win its quiet tug of war. Imagine you are sitting in a dark cabin during a snowstorm. The windows frosted over, the outside world hidden. You cannot see the landscape, but you know it is still there. Mountains, trees, rivers, all wrapped in white. A molecular cloud is like that, except the snowflakes are molecules of hydrogen and tiny grains of carbon and ice. And the cabin is your ship drifting in a place that spans dozens of light years. Somewhere within this dimness, gravity slowly gathers snowdrifts into hills, hills into mountains, until the weight is so great that the core of the cloud fragment begins to heat up, not from a flame, but from the pressure itself. When that central region gets hot and dense enough, nuclear fusion flickers to life, and a new star is born. At first it is wrapped so tightly in its cocoon of gas and dust that almost no visible light can escape. Only longer wavelengths slip through, like the low, soft notes of a distant drum. Astronomers see these hidden cradles with infrared telescopes perched high above the atmosphere or floating in space. And what they find is astonishing. Inside the murk, there are clusters of newborn suns, some only a fraction of the mass of our own, others many times larger. Around some of them, disks of dust and rock swirl like flat whirlpools, the raw material for future planets. One way to picture it is to think about a construction site at night. If you walk past in daylight, you see cranes, scaffolding, workers, piles of steel beams and lumber. But if you come at midnight with only a few dim lights burning, the site looks almost abandoned, quiet, still. Only when you get closer do you notice the glow of welding torches in the shadows, the faint rumble of engines, hidden activity that will eventually turn steel and concrete into a building where people might one day live and work. A molecular cloud is the universe's construction site, and the welding torches are the cores of collapsing gas where stars will soon ignite. Think about our own sun and earth for a moment. About 4.5 billion years ago, all of this was once just part of one such dark cloud, perhaps spanning 50 or more light years across, maybe 290 trillion miles from end to end. Our sun began as a small overdensity in that cloud, a slowly tightening knot of hydrogen, while the material that would become Earth swirled in a dusty disk around that young star. If you could travel back in time and fly through that cloud, you would not see a tidy planetary system, just a thick haze scattered with faint red and orange glows where young suns were struggling to pierce their blankets. Somewhere in that dim chaos, the atoms that now make up your hands, your heart, your brain, were drifting in the cold, waiting for gravity to give them a new home. This is why some astronomers like to say that darkness in space is not absence, but anticipation. When we talk about enormous dark clouds hiding the life of the future, we are not being poetic for its own sake. We are describing a genuine physical truth. Inside these clouds, the chemistry of life is already starting. Simple molecules cling to dust grains. Organic compounds begin to form. And when new stars turn on, their light and winds will eventually disperse the cloud, carrying these ingredients out into young planetary systems. Picture a family driving across a vast rural landscape at night, perhaps in the southwest of the United States, where the towns are few and far between. Out the car window, the child in the back seat sees only darkness between distant farmhouse lights, long stretches of road where nothing seems to exist. The parent, though, knows that in those dark fields there are seeds in the soil, animals sleeping, rivers quietly flowing, life everywhere. Space is like that drive, and molecular clouds are those unseen fields. The road trip analogy helps us feel the scale as well. On Earth, a long drive might be 1,000 miles across several states, something you could cover in a couple of long days. Crossing a molecular cloud even at the speed of light would take decades. 50 light years for a medium-sized cloud means 50 years of travel for a beam of light, moving at about 186,000 miles per second. A speed no human-made ship can come close to yet. So when we say these are enormous dark clouds, we are talking about regions whose widths dwarf the entire orbit of Neptune. Regions where you could fit our whole solar system many times over and still have room to spare. In a YouTube story, guiding viewers gently through this landscape, you can invite them to imagine their own ship easing into the gloom, the cabin lights dimmed, the hum of the engines soft and steady. As the bright belt of the Milky Way fades behind them, the narrator can slow their voice, letting each image stretch out like the distant miles of an empty highway. They can describe how the instruments aboard the ship still register a rich and complex environment, even when the windows show almost nothing. Radio receivers hearing the whisper of molecules, infrared cameras sketching the outlines of hidden stars. Step by step, the audience begins to feel a quiet shift in perspective, from thinking of darkness as empty to seeing it as full of potential. And then, just when the stillness feels absolute, the story can reveal a faint reddish glow ahead, the first sign of a protostar pushing against its shroud. This glow is not yet a fully formed sun, but it is already reshaping its surroundings, sending out jets of gas, carving cavities in the cloud. One day, planets may condense from the leftover material, and on one of those worlds, life could arise, look up at its own night sky, and wonder about the dark patches where the stars disappear. So when we talk about giant dark clouds that hide the life of the future, we are really talking about the deep continuity between the most silent parts of the universe and our own breath in this moment. The atoms in our bodies once drifted in such a cloud, and the atoms that will one day belong to other beings are drifting in similar clouds right now. To sit with that thought, slowly, like a quiet meditation, is to feel the universe not as something distant and cold, but as a vast unfolding story in which darkness is simply the chapter before the light. Have you ever realized that the iron flowing quietly in your blood once rode the front of a cosmic shockwave tearing through space at thousands of miles per second? That the calcium in your bones was once part of a star that died so violently that its outer layers were thrown off like petals in a storm? When we talk about shockwaves from supernova explosions, we are not talking about something far away that has nothing to do with us. We are talking about the story of our own bodies, written in the language of fire and expansion. Imagine a massive star reaching the end of its life, after millions of years steadily burning lighter elements into heavier ones in its core, feeding a delicate balance between inward gravity and outward pressure. One night in the distant past, long before Earth had oceans or trees or curious creatures staring at the sky, that balance failed. The core collapsed in a heartbeat, matter falling inward at a significant fraction of the speed of light, then rebounding in a titanic burst of energy. The star did not simply fade away. It detonated. From that instant, a shockwave surged outward into the surrounding space. a thin but incredibly energetic shell of gas and particles plowing into everything in its path. In just 1 second, that front could cover hundreds of thousands of miles, crossing the distance from Earth to the Moon in less time than it takes you to breathe in and breathe out. It swept through the local clouds of gas and dust, compressing them, heating them to millions of degrees, leaving behind a bubble of hot, glowing material that would keep expanding for tens of thousands of years. If you could stand at a safe distance and watch this unfold in slow motion, you would see something like a great flower opening in the dark. Filaments and arcs of gas stretching outward, curling and twisting as they race away from the dead star. The edges of the shockwave would glow in X-ray and ultraviolet light, invisible to your eyes, but blazing in the detectors of our telescopes. To those instruments, the remnant of a supernova looks like a rippling shell, a delicate lace of glowing gas tens of light years wide, still moving at thousands of miles per second, even long after the initial blast. Now, bring this closer to home with a simple picture. Think of a quiet lake at dusk. You toss a stone into the water. Ripples spread outward in perfect circles, each ring carrying a little of the stone's energy away from the center. A supernova shockwave is like that. Only the lake is a vast cloud of gas 100 light years across. The stone is a star, 30 times the mass of the sun. And the ripples are moving at unimaginable speeds through a medium so thin it is almost a vacuum. But just like the ripples on the lake, the shockwave carries information and energy outward, shaping everything it touches. Here is where the story becomes personal. Inside that star, before it died, lighter elements like hydrogen and helium were fused into heavier ones. Carbon and oxygen, and silicon and finally iron. In the last fraction of a second of its life, during the explosion itself, even heavier elements were forged in the furnace of the blast. Gold and uranium and many others. The shock wave became the delivery system, throwing these newly created elements out into the galaxy, mixing them with the interstellar gas the wave was plowing through. Every atom of iron in your red blood cells, every bit of calcium that makes your bones solid enough to stand against gravity, was once caught up in such a wave. Picture an old rusty nail in a wooden fence on a small farm in the countryside of the United States, its head flaking with reddish-brown crust, driven decades ago into a weathered post. To most people, it is just a piece of scrap metal. But if you could trace the atoms of iron inside it back through time, you would eventually leave Earth, leave the solar system, and arrive at the expanding shell of some long-forgotten supernova. That nail, the tools that built the farmhouse, the hemoglobin in the farmer's blood, all of it carries the fingerprint of shock waves that shook the galaxy before our planet even existed. Think about the first time a child in that farmhouse gets a simple blood test at a clinic. A nurse draws a tiny vial of dark red liquid, labels it with a name and a date, and sends it to a lab. Under a microscope, a technician sees countless red cells, each one a little carrier of oxygen thanks to a core of iron atoms. That quiet scene, fluorescent lights humming, white coats moving slowly between machines, is connected to an explosion that once outshone an entire galaxy, its shockwave still racing outward through space. In that sense, a hospital in a small American town and the wreckage of a star thousands of light years away are part of the same story. Shock waves from supernovae also help sculpt the next generation of stars. As they move through the galaxy, they compress some clouds of gas and dust, triggering them to collapse under their own gravity. In those collapsing regions, new stars are born, many of them with planets. Some of those planets rocky, with surfaces where liquid water can pool. Our own solar system may have formed in such a neighborhood, in a region influenced by one or more ancient supernova shockwaves, sprinkling heavy elements into the cloud that would one day become the sun and its worlds. Without those waves, there might never have been enough heavy material in our region of the galaxy to build a planet like Earth, with continents and oceans and living cells capable of thinking about their origin. From the perspective of a cosmologist, these explosions are not random acts of violence. They are part of a cosmic recycling system. Stars are born, live, and die, and their deaths send shock waves that seed the galaxy with the raw material for the next generation. From the perspective of a philosopher or a poet, it is hard not to feel something deeper in this pattern. When you stand under the night sky and place a hand over your chest, feeling the steady beat of your heart, you are feeling the quiet echo of those long-ago detonations. Every pulse is a reminder that the universe once shook itself violently to make it possible for you to be here, breathing and wondering. So next time you see an image from a space telescope showing a delicate shell of gas in some distant constellation, remember that you are not looking at the wreckage of an event that is over. You are looking at a wave still moving, still shaping the galaxy, still carrying heavy elements into new places. Somewhere within that expanding shell, new clouds are being compressed. New stars are beginning to glow. And perhaps, unimaginably far in the future, new beings will stand under their own skies and ask the same questions we ask tonight. In the soft pace of this realization, something in us becomes very quiet. We see that shock waves from supernova explosions are not just dramatic scenes in a science documentary. They are the hidden bridges connecting our everyday lives to events on a galactic scale. The rust on an old nail, the strength of a child's bones, the red tint in a drop of blood. All of it is evidence that we are woven into the aftermath of dying stars. And as we breathe slowly, letting that thought settle, we might feel a quiet humility, a sense that the universe is not out there and we are in here, separate and small, but that we are one continuous story, written in shockwaves and starlight. Have you ever looked up at the Milky Way and wondered what it would feel like to leave that pale band of light far behind and then enter right into its glowing heart? To step out from the quiet darkness around our solar system and suddenly find yourself on a bright galactic highway where every star burns like a street lamp stretching off for tens of thousands of light years. As we move deeper into the direction of Taurus, that is exactly what begins to happen. The soft smear of the Milky Way that we see from a backyard or a driveway at night stops being just a faint stripe across the sky. It becomes a true avenue of light. Imagine riding in a car on a lonely interstate somewhere in the American Midwest at 2 a.m. The world outside the windshield is mostly darkness. But then in the distance you notice the glow of a city. At first it is only a haze on the horizon. Then individual lights appear. Then billboards, gas stations, house windows, rows of lamps along the highway. Our journey into the arms of the galaxy is a little like that, except the city is made of hundreds of billions of suns, and the highway is more than 100,000 light-years wide. We began far from here, lifting off from Earth, leaving the comfort of our blue planet, where distances are measured in miles and feet, 300 miles to low Earth orbit, about 238,000 miles to the Moon, a few billion miles to the edge of the solar system, where the sun becomes just another bright star behind us. At that scale, even the orbit of Neptune is still a small bubble in a vast ocean. Out between the stars, the numbers change. 1 light year is about 6 trillion miles, a number so large that it no longer fits comfortably in our daily thinking. But as we head toward Pleiades, we are dealing with more than 440 of those light years, more than 2.5 quadrillion miles. To make that less abstract, imagine driving on a straight highway at 60 miles per hour without ever stopping to sleep or to eat. Not for a day, not for a year, but for the entire age of modern human civilization, 10,000 years. You still would not even come close to crossing a single light year. And yet, we need hundreds of those to reach the little blue cluster glittering in Taurus. As we sink deeper into the plane of the Milky Way, the feel of space around us changes. For most of the trip between stars, the sky is sparse. A few bright suns here and there, big patches of black, thin wisps of interstellar gas colder than -450 degrees Fahrenheit. But the galaxy is not empty. It is a great rotating disk about 100,000 light-years across and a few thousand light-years thick. And we are now sliding along inside one of its spiral arms. The number of visible stars around us starts to climb. First dozens, then hundreds, then tens of thousands. It is like flying above a major city at night and watching the isolated farmhouses give way to suburbs and then to downtown, where every street intersects a web of glowing windows and traffic lights. In this brightened region, the Milky Way is no longer something we look at from the outside. It is something we are inside, like a firefly drifting through the beam of a giant flashlight. Stars rush past us not in the sense that we move quickly between them, because even at a fantastic fraction of the speed of light, it would still take years to go from one to the next, but in the sense that our view changes. Constellations warp. Familiar patterns fall apart. On Earth, we draw Taurus as a bull outlined by a few bright points. Yet here in the galactic arm, we see that those points belong to different neighborhoods. Some closer, some farther, some sitting in front of drifting clouds of hydrogen that glow in soft reds and pinks under the harsh ultraviolet light of hot young suns. To help picture this, think of driving through a dense fog on a coastal highway at night. The light from each car ahead of you blooms and smears. Distant houses appear as vague halos before sharpening into clear shapes when you draw nearer. Now replace the fog with interstellar dust that stretches for dozens of light years, and the car headlights with stars many times larger than our sun. Some so bright that if they traded places with the sun, your backyard would be too hot for life. This is the kind of environment we enter as we push toward the heart of the spiral arm that hosts Pleiades. Somewhere behind us, if we were to turn around, our own sun would blend into this river of lights. Just one more yellow star among hundreds of billions, orbiting the center of the galaxy at about 500,000 miles per hour, taking more than 200 million years to complete a single lap. When dinosaurs walked on Earth, the sun was in a different part of this great galactic orbit. When early humans learned to shape stone tools, it had moved again, and by the time modern observers first recorded the Pleiades in ancient star myths, our entire solar system had drifted to yet another district in this shining city of stars. Realizing this, we begin to feel less like travelers leaving home and more like passengers who never stopped moving in the first place. Ahead of us, the glow of Pleiades sharpens. When seen from Earth, it looks like a tiny pinch of crystals, maybe 6 or 7 bright points, easily visible to the naked eye on a clear night away from city lights. A child on a farm in Kansas, lying on the bed of a pickup truck on a cold autumn evening, might stare up and notice that little cluster near the shoulder of Taurus, not knowing its name, only feeling that it is different from the other stars, more concentrated, more alive. Years later, that same child, now an adult, might hear that the light from those stars has been traveling for centuries to reach their eyes. That when the first European settlers crossed the continent on foot and wagon, the photons now hitting their backyard already began their journey. This simple realization turns that tiny patch of glitter into a bridge across time, and our imaginary journey turns it into a bridge across space as well. As we approach Pleiades from within the galaxy, the cluster stops being a tiny knot and becomes a real neighborhood, a group of hot blue stars only a few light years apart from each other, wrapped in a faint veil of dust that scatters their light into a soft electric blue sheen. Around them, countless fainter stars form a background tapestry, like apartment windows in a vast city skyline. The Milky Way here truly feels like a boulevard, bright lanes of starlight stretching in arcs above and below, side streets of dimmer suns, dark alleys of dust, clouds where future stars are still asleep in cold silence. We realize that what we once called a constellation is really only a local pattern we draw from a great three-dimensional ocean of suns, a pattern that melts and reforms depending on where we stand. The transition from empty interstellar dark to this crowded stellar district mirrors something in our own lives. There are phases when we feel like we are drifting in a lonely space. No landmarks, no signposts, just the sense of moving through time without much change. Then we cross an invisible threshold and suddenly everything becomes dense. Opportunities, relationships, challenges, lights switching on all around us like the approach to a brightly lit city after miles of emptiness. The galaxy is not only a physical structure, it is also a metaphor for the inner maps we draw as we move through our own stories. As we glide deeper into the arms of the Milky Way, the presence of Pleiades ahead gives our journey a clear direction. Yet the space around us whispers that the destination is only part of the meaning. Every star that passes to our left and right, every cloud of gas we cross, every faint red dwarf hiding in the shadows, is a reminder that the galaxy holds far more worlds than we can ever visit. We are not just moving toward a cluster of stars. We are learning to see our home galaxy from within, to feel its rotation, its breadth, its quiet persistence across billions of years. In this calm, almost meditative drift along the galactic avenue, the mind slows down. The heart rate seems to sync with the long sweep of cosmic orbits, and a deeper question arises. If our tiny sun is just one lamp along this infinite highway, then what does it mean that on a small planet circling that lamp, a species has appeared that can imagine this entire journey in thought alone? With that quiet question echoing, we let the river of stars carry us a little farther, until the 7 bright lights of Pleiades stand before us more clearly than ever, inviting us to come closer and learn what stories wait inside their blue embrace. Have you ever wondered how something so small in the sky can still feel like an entire world calling you across the dark? From your backyard on a cool evening, you look up and see a faint cluster of blue-white sparks just above the line of the trees. Not as obvious as the moon or the bright planets, but strangely magnetic. That little knot is the Pleiades, and if you could drift through space to within 50 light-years of it, the view would no longer be a tiny smudge on velvet. It would become a bouquet of torches hanging in front of you. Imagine riding in a ship that has left our sun far behind, so far that our own star is just another modest glimmer in the background. Ahead of you, the Pleiades swells in the windshield like a city seen at night from an airplane, each young blue sun shining with a light that feels cold and sharp, like starlight on fresh snow. Astronomers tell us that the brightest 7 stars in this cluster are only a few 100 million years old, teenagers on the timeline of the galaxy. Our sun, by comparison, is more than 4.5 billion years in age, an old adult beside these youthful giants. If you think about a human life lasting perhaps 80 years, then the age of these Pleiades stars would be like a child who has just discovered the world outside the front yard. Their light is fierce, hot, intensely energetic. In physical terms, they are what astronomers call blue type B stars, burning much hotter than our yellow sun. But in emotional terms, you might think of them as restless teenagers, bright, loud, living fast. They will not live as long as our star, but in the time they have, they flood their surroundings with light, heat, and stellar wind. Now picture the cluster plunging through a vast cloud of interstellar dust, a kind of cosmic fog stretching for light years. This dust is made of tiny grains smaller than smoke particles, but across distances of trillions of miles, it becomes thick enough to shape what we see. When the blue light from those young stars hits the dust, it scatters, just like sunlight scatters in our atmosphere to make the sky appear blue. So around the Pleiades you get these pale electric veils, wisps that seem to glow on their own, yet are really just reflected starlight. To someone standing on an imaginary planet near the edge of that cloud, the sky would be filled with slow-moving curtains of silver-blue mist, like frozen auroras stretching from horizon to horizon. To make this easier to feel, imagine you are driving across the deserts of the American Southwest at night. The towns are far apart, and for hours you see nothing but darkness and the low glow of your headlights on the road. Then far ahead a city begins to rise on the horizon, not as a single point of light, but as a cluster of shimmering blues and whites. Street lamps, buildings, headlights on distant freeways. It looks small at first, but as you approach, details emerge. Reflections appear in the air from dust and moisture, halos around lamps. The Pleiades at 50 light-years may be something like that. Not just 7 points, but a glowing district in the great city of the Milky Way. If you could pause your ship in that region and simply float, the silence would be overwhelming. There is no air to carry sound, only the quiet hum of your own thoughts. Yet visually the sky would feel crowded, not empty. The 7 famous stars would not be alone. The Pleiades is actually a family of hundreds of stars bound together by gravity, many of them too faint for our naked eyes on Earth. But from within the cluster they would form a dense tapestry, like being inside a swarm of fireflies that never go out. Some would shine bluish-white, some more modest and pale. Between them, lanes of dark dust would thread the sky, subtracting light rather than adding it. The effect might be similar to looking up through bare winter branches at a sky full of streetlights, brightness and shadow intertwined. There is something strangely human about the way we have named these stars. We see 7 bright points, and we think of 7 sisters, 7 daughters, 7 maidens fleeing across the heavens in Greek stories. In Japan, the same cluster is called Subaru, meaning to unite. In other cultures, it is a nest of doves, a clutch of seeds, a gathered family. When you realize that ancient people on different continents all looked at the same patch of sky and felt the need to tell a story about it, the Pleiades stops being just an object made of gas and plasma. It becomes a mirror for the human mind. You can imagine a hunter thousands of years ago on a cold night in what is now North America, crouched by a small fire, looking up and noticing the little blue cluster rising before dawn. For that person, the Pleiades might have been a calendar, a signal that winter was deepening, that certain animals would be on the move. The same cluster you see from your backyard today guided their stories, their journeys, their sense of time. From a scientific lens, there is another quiet wonder in the idea that the cluster is moving through a dust cloud rather than sitting inside the one it was born from. The dust and the stars are probably not siblings, but travelers who happen to cross paths. It is a cosmic coincidence that at this moment in galactic history, our line of sight catches the Pleiades while it swims through this filament of material, dressing the cluster in gauze for our eyes. On another world, in another epoch millions of years from now, the same stars might look quite different. No blue veils, no silver mist, just raw starlight against the dark. In that sense, what you see tonight through a small telescope in your yard is a fleeting stage, set on a stage that spans the galaxy. To grasp the distances involved, think of a single light year as about 6 trillion miles. 6 trillion is a number so large that our everyday comparisons break down. Yet we can still try. Suppose you drive across the United States from coast to coast, a trip of about 3,000 miles. You could cross the continent 1,000,000 times, back and forth, and you would still fall short of a single light year. Now multiply that by 50, and you have the distance from our imagined stopping point to the glowing heart of the Pleiades. Even at the speed of light, it would take half a century to close that final gap. At the speed of current spacecraft, the journey would last longer than human civilization has existed. Yet your mind leaps it in an instant, just by following this story. There is a calm wisdom hidden in that realization. Physically, we are rooted to a small world circling an ordinary star, but mentally we can stand 50 light years from the Pleiades and watch the cluster rise like a blue lantern in the cosmic night. When you slow your breathing and picture the scene, the dust glowing, the teenage stars burning high, the Milky Way arching behind them, something settles inside you. The rush of daily worries, appointments, deadlines, noise begins to shrink. In their place comes a soft question, almost a whisper. If a cluster of stars halfway across our spiral arm can touch my heart from so far away, what does that say about the strange thread that links consciousness and cosmos? Maybe that is why the Pleiades has always felt close even while it remains impossibly distant. It is not just that the cluster seems to be drawing nearer in our field of view as we imagine approaching it. It is that every time a human being looks up and notices those blue sparks, the gap between star and soul contracts a little. For a moment, you are not only a person standing on a patch of ground in one country or another, you are a witness to a living galaxy, watching the youthful fires of the Pleiades carve their way through a cloud of ancient dust. In that stillness, under that quiet blue flame, the universe feels less like a distant machine and more like a story still being told. And tonight, simply by raising your eyes and letting them rest on that small cluster, you have become part of that story. What would it feel like to stand inside a star cluster that you have only ever seen as a tiny misty patch in the night sky? To lift your eyes from a quiet backyard on Earth, and then in your mind step forward until those 7 little sparks that we call the Pleiades grow and grow, until they become suns hanging above you like lanterns in a cosmic city. When we speak of reaching the heart of the Pleiades, we are not just talking about traveling 440 light-years across space, which is roughly 2.5 quadrillion miles in the units used every day in the United States. We are talking about traveling into a different way of feeling distance itself. As you move deeper into the cluster in your imagination, the first thing you notice is the dust. Not the kind of dust that gathers on a bookshelf, but grains smaller than smoke, floating between the stars, each one catching starlight and scattering it in a soft blue glow. From Earth, all of those scattered rays blur together and paint the Pleiades with that dreamy faint haze that telescopes capture so beautifully. But from up close, it would feel more like standing inside a dimly lit cloud, with light seeping through it from every direction. Imagine driving your car on a foggy night with your headlights on. The beams do not cut sharply into the distance. They bloom and soften, and the air itself seems to glow. Inside the Pleiades, that glowing fog would be made not of water droplets, but of ancient cosmic dust enriched by long-dead stars. Astronomers tell us that the stars in the Pleiades are young, only about 100 million years old, which in cosmic terms is the age of a teenager. They burn hot and blue, pouring out energy far more intense than our middle-aged sun. Now think about the distance between these suns. In our part of the Milky Way, the nearest star beyond the sun is more than 25 trillion miles away, so far that light itself takes over 4 years to travel that gap. If we tried to express that in familiar highway terms, driving at 60 miles per hour without stopping, it would take nearly 50 million years to go from the sun to that neighboring star. Inside the Pleiades, by contrast, the stars are packed much more tightly together, perhaps only a fraction of that distance apart. More like close houses in a city instead of lonely farmhouses on a distant prairie. To make that even more concrete, imagine shrinking the sun down to the size of a porch light on a quiet American street. In our region of the galaxy, the next porch light would not be at the end of the block, or even in the next neighborhood. It would be hundreds of miles away. But in the heart of the Pleiades, if one star were a porch light, the next one might be only a few miles down the road. The sky around you, filled with bright lamps in every direction. You would not be living under a mostly dark sky dotted with a few distant points. You would feel as if you were in the middle of a vast, luminous metropolis, a true city of light. Think for a moment of standing on a hill outside a large city at night, perhaps somewhere in the American Midwest or along the East Coast. The downtown skyscrapers glow. Highways trace bright rivers of headlights. Suburbs flicker like constellations laid down on the land. Now imagine lifting that pattern up into 3 dimensions, stretching it not just across a flat landscape but all around you in a sphere, hundreds of billions of miles wide. Every point of light, not a building but a sun, each one with the potential to host its own planets and stories. That is a little closer to what the center of the Pleiades might feel like. In this calm mental journey, time also changes its meaning. The light that reaches your eyes on Earth tonight left the Pleiades around the time European settlers were crossing the continent on foot. Long before electric power or airplanes or the interstate highway system existed. If a civilization were living on a planet inside that cluster, and they had powerful telescopes pointed toward us, the Earth they would see right now would be our world centuries ago. They would not see satellites or city lights from space. They might not even see the same coastlines, because rivers and deltas slowly reshape the face of the planet over time. When you truly let that sink in, the idea of distance stops being only about miles or light years. It becomes about history, about memory. There is another layer to the story of those tiny dust grains that reflect the blue light of the Pleiades. Many of them contain elements like carbon, silicon, iron, and oxygen. Those are the same ingredients that make up our bodies and our rocks and our air, forged long ago in other generations of stars that lived, exploded, and spread their ashes through the galaxy. So when you picture each faint streak of reflection nebula around the Pleiades, you are really looking at recycled starlight bouncing off recycled stardust. Carl Sagan once said that we are made of star stuff. And here in this cluster, that idea becomes almost literal. Scenery. The roads and buildings of our imagined city of light would be paved with the ashes of old suns, glowing under the brilliance of new ones. To help bring this even closer to daily experience, imagine you are walking through a small town just before dawn. The streetlights are still on, fog hangs low over the road, and every beam of light creates a halo around each lamp. Your footsteps are slow. The air is cool. There is a gentle hush over everything. The Pleiades at their heart might carry a similar feeling, not noisy or chaotic, but quietly radiant. Gravity binds the stars together, guiding them in a slow, shared dance around the center of the Milky Way, just as unseen rules of traffic and architecture give shape to a human city. From a scientific point of view, clusters like the Pleiades are laboratories where we can watch how stars are born, evolve, and eventually drift apart. Over hundreds of millions of years, the gentle tug of the galaxy will gradually pull these suns away from one another, stretching the tight knot of the cluster into a looser stream of stars sprinkled through the sky. Someday far in the future, perhaps long after our own species is gone, the familiar little patch of Pleiades that humans have told stories about for thousands of years will fade and lose its shape. The city of light will dissolve. The neighborhood will be gone. And yet, right now, in this brief overlapping moment of cosmic time and human time, we are here to witness it. Parents can point it out to their children on a crisp November night in the Northern Hemisphere. Sailors once used it as a sign of the changing seasons on the ocean. Indigenous cultures across the Americas told stories about 7 sisters or 7 hunters or 7 fires burning in the sky. Inside that shared act of looking up, the unimaginable mileage to the Pleiades collapses into a single intimate gesture, a finger raised to the stars. So when we talk about touching the heart of the Pleiades, we are doing more than playing with astronomical numbers. We are allowing ourselves to slow down, to breathe, to let the mind drift gently along a path that stretches hundreds of trillions of miles, and yet begins in the most ordinary places, on porches, in driveways, at the window of a quiet bedroom somewhere on Earth. The distance becomes a kind of meditation, a reminder that even in a universe so vast that our usual sense of scale almost breaks, Light can still travel. Stories can still travel. And a small cluster of young blue suns can still find its way into the human heart. What does it really mean to say that the Pleiades are 440 light-years away? When we hear that number, it sounds like a piece of trivia, something scientific and distant, but not really real in our daily lives. Yet, behind that single phrase, there is a journey so long that it stretches beyond every road we have ever walked, every flight we have ever taken, every story we have ever told about distance. To feel it, we have to slow down, breathe, and let our imagination do the traveling that our bodies cannot. A single light year is the distance that light itself travels in one Earth year, moving at about 186,000 miles every second. If you tried to express that in miles, it would be about 5,800,000,000,000 miles for just one light year. And to reach the Pleiades, you would need to stack that distance 440 times. We are talking about something like 2.6 quadrillion miles, a number so large that our minds almost refuse to hold it. Imagine getting into a car on some quiet American highway at night, setting the cruise control to 60 miles per hour, and never stopping. You do not stop for fuel. You do not stop for sleep. You simply drive in a perfectly straight line through space at 60 miles per hour toward the Pleiades. To travel one single light year at that speed would take more than 10 million years. And our journey would be 440 times that. By the time you arrived, human beings, as we know them today, would be ancient history. Continents would have shifted. Stars would have changed in the sky. The very idea of you and your car would feel like a myth whispered by some distant civilization. Or think about the fastest spacecraft we have ever launched, like the Parker Solar Probe, racing around the Sun at over 430,000 miles per hour. At that incredible speed, you could circle the Earth in just a few minutes, cross the distance from New York to Los Angeles in less than a minute. And yet, to travel a single light year would still take thousands of years. To cross 440 light years would require timescales that erase nations, languages, and entire chapters of human history. When we say 440 light years, we are really saying this. No ship we can build today will ever carry us there within a human lifetime. And yet, in a quiet and mysterious way, we have already made that journey. Imagine a child standing in a small town in the American Midwest, maybe in Kansas or Nebraska, on a crisp fall night when the air is dry and the sky is clear. The streetlights do not reach very far. The houses are dark, and above the silent silhouettes of trees, the Pleiades shimmer like a tiny blue cluster. That child looks up and asks a simple question to a parent or a grandparent. What is that little group of stars? In that instant, without knowing it, the child's mind travels across 2.6 quadrillion miles, riding on beams of ancient starlight that left their home long before the United States even existed as a country. The light that touches the child's eyes began its journey when no one alive today had yet drawn a breath, when the stories we now call modern were still unwritten. The distance is enormous, but the connection is immediate, and it is built from nothing more than a glance and a question. Picture another scene. An astronomer at a small observatory somewhere in the American Southwest, maybe in Arizona or New Mexico. She spends her nights guiding a telescope toward the Pleiades, not because she expects to fly there, but because she wants to understand the young stars inside that cluster. She adjusts delicate instruments, collects faint spectra, studies the glow of blue-white suns wrapped in wisps of interstellar dust. To her, the 440 light-years are not just a wall of empty space. They are a bridge made of information. Every photon that hits her detector is a messenger that has crossed that entire gulf at the speed of light, carrying news about temperature, composition, and motion. In a way, she is quietly greeting stars that were already burning in the sky when Galileo was still alive. Stars that will keep shining long after we are gone. The distance humbles her, but it also gives her a sense of belonging to something vast and continuous. Now imagine an older person sitting alone on a porch in a rural American town, perhaps somewhere in the South or in the Rockies. They have lived through wars, recessions, personal losses, and small private joys. Their body has slowed down, but their mind still wanders. One night they look up and recognize the Pleiades from some childhood memory, a story a parent once told about the seven sisters or a winter sky. The same light that touched their eyes as a child touches them again now. But that light spent 440 years in the dark between stars to arrive tonight. Human life is fleeting compared to such a journey. Yet there is a kind of gentle comfort in that imbalance, as if the cosmos were saying, "I have been here before you, and I will be here after you. But for this moment we are sharing the same sky." When we turn our back and look away in our imagination from the Pleiades, and mentally retrace the path back home, the Earth shrinks to a speck in the Milky Way. Our cities, our borders, our arguments over land and belief all fold into a single tiny point of light. From that perspective, the phrase "a dot in a sea of stars" is not poetry. It is geometry. Yet this is not meant to make us feel meaningless. It is meant to invite us into a deeper understanding of what it means to be small and aware. We are small in size, but we are vast in perspective. No other creature we know can take numbers like 440 light-years and 2.6 quadrillion miles and turn them into a story, into a question, into a sense of wonder that keeps us awake at night. A cat or a bird or a whale lives beautifully in the present moment, but humans carry the strange gift and burden of being able to imagine distances and times we will never personally cross. That imagination is an act of courage, because it forces us to face how limited we are, and yet how connected we can feel to what lies beyond those limits. The lesson hidden inside the number 440 light-years is not that the universe is too big to care about us, but that our minds are big enough to reach across that space in an instant. Sitting in a backyard in Texas, or a park in Oregon, or on a balcony in New York, we can close our eyes, breathe slowly, and picture the long, dark corridor between the sun and the wine, Pleiades. We can imagine leaving the orbit of the Earth, gliding past the Moon, crossing the paths of Mars and Jupiter, then leaving the whole solar neighborhood behind. We can picture drifting through the thin gas between stars, past ghostly remains of exploded suns, until a small blue cluster begins to brighten ahead. In a few heartbeats, we cross a distance that would take physical travelers millions or billions of years. All of this happens because a question opened the door in our minds. How far is it really from here to there? When we say that the Earth becomes a nearly meaningless point against the Milky Way, we are also saying something quietly beautiful, that every fear and every conflict we cling to so tightly is taking place on a speck so small it would vanish in the glare of a single star. That realization can soften us. It can loosen our grip on the things that do not truly matter, and make more room for curiosity. kindness, and humility. The road to the Pleiades may be impossibly long in miles, but the path to a wider heart and a calmer mind is only as long as one slow breath under the night sky. So, when you next hear someone say that the Pleiades are 440 light-years away, you can remember that this is not just an abstract measurement. It is a silent invitation. An invitation to step outside for a moment, to look up from your driveway or your porch or your apartment window, and to let those distant blue stars remind you of how far light can travel and how far your own awareness can reach. The distance is vast, but in the simple act of looking up you have already crossed it.